All right, good afternoon, gentlemen. If you're watching this video, it means that we were unable to discuss it within the lab on Tuesday or Wednesday this week. If you're watching it and it's Thursday or Friday, this is for you for virtual, so that way you know what you're doing. And if you're here just for fun, hey, what's up? How's it going? So the plan today is I'm going to go over stuff that we'd be doing in the lab, specifically a scientific method if you're writing a lab report. So to begin, doing science is something where it really starts with a question, so we can have a conversation with people. For example, 4 students were having a discussion about how scientists do their work. This is what they said. Matthew says, I think scientists just try out different things until something works. And Zachary goes, I think there's a definite set of steps all scientists follow called the scientific method. Marcus can say, I think the scientists use different methods depending on their question. And Jacob goes, I think scientists use methods, but they all involve doing experiments. Starting to do science, it's really just a question and a conversation. So all 4 of these gentlemen have a wonderful set of ideas, and then they can study and do test and find out, like, hey, how did they do it? But they do use the scientific method to solve for their lab. And the scientific method, we broke it down previously before. It's something that we've discussed. You probably learned about it on more than one occasion. But really, for you to know, it's what really guides our experiments, and it helps guide our lab report outline. So, the scientific method consists of these 6 steps always. And it's always you ask a question, you make a hypothesis, then you test your hypothesis with the lab, you analyze those results, you make a conclusion, you tell me, hey, is my hypothesis true? Is it not? And then I communicate the results. My lab report really follows that scientific method. It's my outline because I have to ask a question. I make my hypothesis. That's my beginning. I test it. That's my experiment. Then I have to graph. I analyze those results. I make a conclusion. And then I have to tell someone, like, hey, this is what I found. And so a lot of the, hey, this is what I found is what you turn into me. That's your excitement. Yes, I solved this. That's how you know. So an example is that Mrs. McCaslin notices that some of her students are a little sleepy in the morning and thinks that Red Bull energy drink will increase the productivity of her students so they can learn more science. So I say, more Red Bull, you get more science out of it. So I can give my students, they'll come in and I give them different amounts of Red Bull. So I can give someone, here's a little sip. Here's maybe a half of a can. Here's a full can. Maybe here's 3 cans. I don't know. Just I'm increasing the amount. And I do it for 7 days. And during that time, I give them amount of problems and I time them for 30 minutes and I record down how many problems they complete. So from the example, what is the question that I'm asking before I perform the experiment? What I'm asking is I'm saying I want my students to be more alert and I want them to complete more science problems. And I think for them to complete more science problems, they need Red Bull energy drinks. So my hypothesis is the more Red Bull you have, the more problems you'll complete because you'll have more energy. I test it by giving the students different amounts of Red Bull, and then I see in 30 minutes how many problems they can complete. My next step is I need to analyze and say, hey, is my hypothesis true or is it not? Now, applying the method, you could do it in a scientific lab report. We change the names of everything, and then you have to outline it in this specific order. You always start with your purpose. Then you move to your introduction. You tell me about the materials and the methods you used. You tell me about the data that you collected, your analysis, and then the conclusion that you draw. Your purpose is always a complete sentence, and it's stating the reason you're performing the lab. So the lab is performed to test the amount of, if more energy means more math or science problems. And then identify my independent and my dependent variables. Now, if you're watching this and you haven't seen the graphing lecture, excuse me, I'm going to give you a little reminder to make sure you look at the graphing lecture. It's going to be a lot more helpful. Your independent variable is what you're changing. So I'm changing the amount of Red Bull my students drink. My dependent variable is what I measure. So in this case, I'm measuring how many problems they can complete in 30 minutes. So I identify my variables, which you did at the top of your lab. Then you need to give me a control. And as a reminder, your control is something that's not changing in the environment. Then you'll write your purpose down, and a lot of the time you include your independent, your dependent variables. Next, you're going to need introduction, and this is always a mini paragraph, so 2 to 4 sentences, but complete sentences, and it gives detail to the purpose. So the purpose is like, here's my snippet, here's my cliff notes of what this is, my introduction is, here's some more information, here's a little taste of what we're studying. And then use some background information that may be useful. So, for example, with the Red Bull, I can say, like, here's my background information on why I'm doing it, or why I think Red Bull, because Red Bull, is energy drink. So it gives you energy, and it has to be scientific. I can't just say, oh, but my mom said this. You have to give me a source. If you find a source, you have to say, Isaac Newton studied this, something like that. Next is your materials and your methods, your complete list of materials. If you are using a toothpick, for crying out loud, you write that down on your materials. I need every single material. Next, you'll do your methods, which is your procedure. So it's your step-by-step. It's numbered in order, and it's detailed and thorough. You can't just say, oh, I gave my students Red Bull. When did I give them? How much did I give them? I have to know. What did I do before then? What did I do after then? You need to give me a detailed procedure on what you're completing. Next is your data and your formulas. So that's where you collect your data. So for example, with this, it was on the back sheet. You collect all of your data for your gum. And then you make sure to include both types of data that you're doing. So if you're doing a table and a graph, you have to have all of it. And if you're doing any formulas as well. After you do that, you do your analysis. That's your graph part. So I take my data and I plug it in a graph. Remember, it's always your X values, your independent, your dependent, your Y, and then your graph title is actually your independent versus dependent. Did not come up for some reason, but this was in your lecture notes. Again, remember, if you don't know how to graph, you're going to watch your graphing lecture. That's going to tell you what to do. After you get all of this stuff together, you make your conclusion. You tell me, hey, my hypothesis that I made, correct or not, but you have to explain why. You can't just say, I was right or I was wrong, and then not tell me why. I need to know, how do you know you're wrong or you're right? You're going to tell me about error that occurred in lab that maybe skewed some of your results. You'll explain that to me, and then you'll tell me about your relationship between your independent and your dependent variable, which, remember, graphing lecture, direct is when they both increase, inverse is when they're opposite, flat line is when X increases, Y stays the same. So you tell me about that. So today, or earlier this week, you're going to be doing the gum lab. This is the lab behind the science of chewing gum. That's where your handout is. First, what's it made of? Chewing gum has been with us since the Stone Age, which is crazy to think. The gum was made from the sap of the sapodilla tree. Most modern gums are based on a synthetic equivalent. It's a rubber material called polyisobutylene that's also used in the manufacture of inner tubes, which is crazy to think. I'm chewing stuff that's used for inner tubes. So the polyisobutylene is mixed with the plasticizers and materials, like food grade materials, so it's safe to consume, to make the gum mixture chewable. So I'm chewing things that are used for like inner tubes, but it's not an inner tube, like equivalent. Cannot just have a bunch of gum and make an inner tube, which would be crazy if I could, but it doesn't work that way. The success of the shekel and polyisobutylene, which is crazy. I can't say shekel, but I can say polyisobutylene. Wild. Lies partly in the narrow temperature range over which materials soften. So, material that's firm and easy to mold becomes soft and pliable in the warmth of the mouth. Crazy. So there's some background information on chewing gum. The purpose is you're going to determine which type of gum's flavor lasts the longest by analyzing how much mass is lost when chewing. The loss of mass, which is your sugar being dissolved, because think about it, your gum becomes less flavored, it's not as sweet, you're kind of like, I don't like this, because you're sucking all the sugar out. So if it's bigger when you start, and it's smaller by the end, all that sugar is being dissolved out, because it's going into you. So your loss of mass equals your loss of flavor. The rules is that you have to record the mass of your gum every minute for at least 8 minutes. You're going to start with 0, so you get time 0, and then every 1 minute, 2 minute, 3 minute, 4 minute. Both types of gum at your lab table must be recorded in your data table. You're going to use colored pencils that I'll have out, and then the gum cannot touch the balance. So you have to use the wrapper and zero out the balance with that. Remember, your loss of mass, which is your sugar being dissolved, equals your loss of flavor. Those are the groups that we had. And I do have this video. I linked it for you to watch to really just get you into the mood. But by the end, you'll be able to complete this lab. So you're going to do the identifying variables. If you have not, remember your variables, or you have time, and then you have the mass of gum. You might write your controls you notice in the lab, your purpose. We've already kind of talked about it, so I have that for you, which is beautiful, right? Makes it a little bit easier. You're going to give me some background information, so I would do it on your iPad, but do that at the end. You're going to do your hypothesis. You're going to write all the materials we use, the methods, and you'll go through, collect your data, and you'll do the analysis on your own. And then you will have to create your own graph, and then you'll make your conclusion. So this won't be due until I see you next. So you have over a week to complete it, which is nice. However, it's just important that you know what you're doing. And so if you have any questions, please email me. But that's all I have with the scientific lab report. And I do show examples to you in class so you get to see like what a professional one would look like. But other than that, I hope you have a wonderful day. Bye.